Hello there. I was just checking my math to make sure I didn't screw this up. Okay, in this problem, I wanted you to find out which one of these three contraptions would have the greatest moment of inertia. So the first one, it's going to spin around on this axis. It's going to go around that way, and this one's going to do the same thing. It's going to spin around like that. It's going to spin around that way. Okay. This one, it's got mass of m, some distance r away from the center. And on the other side, it's got another mass. How far away is it? R. So this mass is spinning around on that path, and this mass is also spinning around on that path. You've got to find the moment of inertia. Same thing for this one, but I have a different m, I have a different r. This time it's less mass. It's 4/9 of the original mass. And instead of being 1 unit of r away from the center, it's 1.5. So I have two of those, 4/9, 4/9, 1.5r, 1.5r. Finally, we have a great big radius of 2r for each of our masses, but this time, although the radius is getting bigger, the mass is getting smaller, I have 1/4 of the mass that I did originally. So I wanted you to find the moment of inertia for all three, figure out which one's bigger. Here's how it works. Moment of inertia, the same formula for every single one, is the sum of all the individual pieces of mass times how far that mass is away from the center squared. And by the center, I mean the axis that it's rotating on. All right, so for the first one, I've got this mass, and it's some distance r away, so I took mr squared, and there's two of them, so I put 2 mr squared. Done. That's it. That's the answer for the first one. What's the moment of inertia? 2 mr squared. Easy. Next, this one, exact same formula. I've got two of them, but this time my mass is 4/9 of what it was originally, and this time the distance from the center is 1.5 r. So when you put this into your calculator, you get exactly the same answer. Crazy. All right, I got 2 mr squared for that one. I got 2 mr squared for that one. Moving right along. This last one. Exact same formula. I got two pieces of mass. This time the mass is 1/4 as much as it was originally. And the only thing that's different is how far it is away from the axis. This time it was r, here it was 1.5, and here it's 2. So, plugged into my formula, I got 2, 1/4 of a mass, times 2r squared. And again, you put that into your calculator, and you get 2 mr squared. So, that's the surprise. The surprise is they all have the same moment of inertia. All right, so hopefully, if you ponder this for a little while, it might lead to a deeper understanding of like what is moment of inertia. If I just had to guess which one had the greatest moment of inertia, I probably would have picked this one because it's got the greatest mass, or I might have picked this one because the mass is farther away. And this one's only got 1/4 as much mass, but it's twice as far away. Turns out, you get the exact same moment of inertia for all three scenarios. There you go. That's how you calculate moment of inertia of points of mass. I'll see you in the next problem.